I'd like you to imagine that your ability to detect sound changed on a seasonal basis. It's kind of a weird thought, right? Most of us associate changes in sound detection with age, where as we get older, our ability to detect certain noises decreases. But this isn't true for all animals. In fact, some animals experience seasonal change and their ability to detect sound. A really cool example of this can be seen in a species of toadfish known as the plainfin midshipman. Midshipmen are a really weird type of fish because they kind of think they're birds. And I don't mean that midshipmen think they can fly. Instead, I'm referring to male midshipmen, which during the breeding season make nests underneath rocks where they call or hum to attract females so that they'll deposit eggs in their nest. You can see a picture of a female midshipman in the bottom left-hand side of my slide. Now, what's really cool is that female midshipmen are better at detecting those male hums during the breeding season. And even more interestingly, estrogen drives this change in female sound detection. Something that we noticed recently is that there's seasonal differences in the density of sound transducing cells, which we call hair cells, on the surface of the female midshipman ear. And you heard me right. Fish have ears. I'm not crazy. You can see an outline of a female midshipman ear in the bottom right-hand side of my slide. Now, if we zoom way in on the surface of that ear and take two photos from snapshots in time, one during the winter non-breeding season and one during the summer breeding season, which we can see right above that ear on my slide, we notice that there's changes in the density of hair cells between the two seasons, where during the summer breeding season, there's a higher density of hair cells, which are responsible for the transduction of sound into an electrical signal that the brain can interpret. My thesis focuses on how estrogen drives this change in hair cell density and how estrogen communicates with these hair cells to produce changes in sound detection in the female midshipman. This research provides a strong foundation for future research that can focus on things like mitigating age-related hearing loss and maybe even preventing hearing loss. Thank you.